Everybody, and welcome to Pandas Challenge number 1, Optimize Custom Grouping Function. So you can find all the challenges under the Dunder Data GitHub organization and under the Pandas Challenges repository. You can also find them as a blog post under my Dunder Data publication and under the Pandas Challenges section, which is just over here. All right, so let's read the challenge. It says, for each state, find the percentage of the total state population made up by the 5 largest colleges of that state. And then we also have to do this while finding the fastest solution, only using pandas. All right, so let's go ahead and look at this data set. It's a very, it only has 3 columns. It has names of colleges and their state and the undergraduate student population for that college. So the goal here, let's read it again, find the percentage of the total population made up by the 5 largest colleges of that state. So this is a group by problem. So first of all, there's 7,500 rows. So this has every single college or university or higher education institution in the United States and all of its territories. So this is a group by problem. We need to group our data by state. So within each state, this is the outline to our problem, right? To our solution. We're going to select just those 5 top colleges per state. So 5 colleges per state, the largest ones. We're going to sum up those populations. And then we're going to sum up the population of all the colleges in the state. And then we'll just divide those 2 numbers together to get the percentage that are made up by the 5 largest colleges. So it's a pretty fairly straightforward question. But there's many different solutions in pandas, and some are going to be much faster than others. All right, so let's go ahead and get started here. So one strategy for group by problems is to not actually group it, and instead to just do it on the entire population. So not by within each state, just find the 5 largest schools in existence, and then just sum by the total. Okay, so let's go ahead and do this here. And maybe it'll help out if we just see just a couple rows here. So let's do this for the entire data set. We want the 5 largest schools. So one way is to use sort values on population. And we can do ascending equals false to go from highest to lowest. So these 5, and there's the head method. If we append that, that looks good. And you know what? So we don't actually... Since we don't really care about the state at this point, let's just go ahead and use the series, the population. So that's good. Maybe we just call it pop for short and have its own variable. Okay, good. So this is the, and we get the top 5. All right. So these are the top 5 colleges. And we can just sum this population. So we can just say, I don't know, top 5 is this. So about 408,000 students. And then we just need to sum up the entire school. So if we do top 5 divided by, let's just say total, give it a name. Okay, top 5 divided by total, then we'll get, okay, so out of the entire data set, 2.5% of the total population is made up by the 5 largest schools. So they, that's the percentage they make up. All right, so that's how you would do it on the entire data set. Another way is actually to use n largest instead of doing sort values. So let's take the pop column again, and there's a nice little function called n largest, and we just have to put in, actually it's defaulted to 5, but I'll go ahead and do 5. So this is actually a a simpler way to get the 5 largest. This is instead of sorting the values and then doing dot head, this gives it to you immediately. So we can just do it in one simple step like this, and we should get the exact same numbers. So this is a much more straightforward and more expressive way to solve the problem, I believe, with n largest. So I believe it's a little bit more readable, right? It just says we want the 5 largest colleges, take the sum, and then we want the sum of everything. Okay. So that's how you do it on the entire data set. So we need to take that logic and just put it into each group. So first let's go ahead and let's go back to college. So let's look at college. So we're going to be using the group by method, and we want to group by state. Now, so yes, so we're going to group by state here. And the thing about group by, so the thing about group by is you get only a limited set of functions you can apply to your group that Pandas gives you. If you want to do any sort of more advanced operation, you have to write your own. You have to write your own function to apply to each group. So before we get started, let's just show how to sum up every single all the population by state. So we can group by is a two-step method. We can append the ag method on the group by object, and then this dictionary says we're going to sum the population. So this will return the population, just the total population by state. So that's fine, but we want to get the top 5, and that's going to be the tricky part. And that's where we need to go up here and just perform the exact same things we did up here, but do it per group. So the way we're going to do this, and we can just call this total for now, is you have to define a custom function. So that's why I say, so solution 1 is going to be a very naive custom function. Let's go ahead and do this. So let's just define a function here, and let's call it just find the top 5. So the way these custom functions work, the way they work in Pandas is that they do send an object into there. It's implicitly passed. So we're going to send exactly just the population series. So when we apply our custom function, it's only going to get access to the series. It's not going to get the name in the state column as well. And that's all we need because it's already broken down by group. We're already saying we're breaking it down by group. So just give us that population. So S here is just going to represent that series, that population. So maybe I should just call it pop, and maybe that's going to be a better variable name. So then we can just pretty much copy and paste what we did up here. And so we're just within the group, so we already did it to the whole. So we need to sort it within each state. So we're just going to get the population of all the schools in that state. We're going to sort them from greatest to least. We're going to take the head, and then we're going to sum them. So this is the exact same thing we just did up here. And then let's get total. So it's really no different than we've already done. And then we're going to return just top 5 divided by total. So this is the exact same thing we did on the whole, but we're going to do it by group. So let's go ahead and enter this in. And now I'm going to do the same thing. I'm going to group by state. And we don't need this anymore, actually. So let's go ahead, and the way we do this, and so we can do, so we want to aggregate and say, an aggregate, the ag means you're going to return a single value from your function. So you need this custom function has to aggregate, it has to return a single value. So we're going to map pop to our custom function. All right, so there's our aggregating column. We're going to say pop, go in here. So take this column and go in here, and you'll become the pop variable. Okay, so so here we go. And so this says run it by state. So it says, in Alaska, which there's probably not too many colleges to begin with, it takes up 96%, those top 5 colleges. So this is Alabama, there's 37%. AS is American Samoa, so they might not even have 5 colleges. So they represent all of the students in that territory and so forth. California is a much bigger state, so there's a lot more than 5 colleges. So the top 5 only take up 7.6%. So again, we're writing a custom aggregation function, and it's being sent implicitly the population column, because I'm telling it right here, send it the population column, and then for each state, it's gonna call this function on every single group. So for all 57 groups, it's gonna call this function. It's gonna do the sorting. It's gonna get the head. It's gonna get sum. Then it's gonna do the sum of the entire series for that state, and then return the total. So it's exactly the same thing we did on the entire data set, but it's gonna be done on just each group. And I'll just take the head of this to return the top 5. All right, so let's move on. So the thing about custom functions, custom group by function, they are difficult to debug. It's difficult to understand the logic that is going on in here. So what you can do is, it's essentially similar to a print statement, and this is something I actually I recommend doing to see the internals and the mechanics of what is going on within a custom grouping function, is that you can inspect it and with some help with the display module from IPython. So this just makes it a nice display in your notebook. You can also just use a print statement here, and that's fine as well. Okay, so this is the same function as above. I've just basically I've simply broken it out into multiple steps. So the first thing we do here, it's the same function again. I'm using the variable s, and I already pre-wrote it because this would be a lot to type out live. So what we're going to do is we're going to sort our values. This is s is population, so I use a different variable name. We're going to sort our values first from greatest to least. I reassigned it to s, and that's fine. So I'm gonna print that out. That's what I'm gonna do. I'm gonna display it, and then I'm gonna grab the top 5. I'm going to display that. So I'm just doing carefully one step at a time, just so we can see what's happening. And then I'm gonna get the total for that top 5. I'm gonna display that, and then I'm gonna get the total for all of the data and display that, and then I'm gonna have my final answer and display that as well. All right, so here is a very similar looking group by statement, except I'm going to use this find top 5 display. So I've executed that, and now let's go in here. Okay, so what pandas does, it actually does by it does the groups alphabetically. So this is actually Alaska, even though, and that's just because I know it actually returns over here. So AK. So here's Alaska. These are all the Alaska schools. So that's what it does. It just sorts the schools. Oh, and one last thing. So this is important. This function doesn't actually return anything. I force an error to be raised. So this is so that I don't want to print out all 57 groups. It would just clog up my notebook and take a lot of time. So that's important here when you're inspecting groups. So raise forces Python to raise an error, which means that it'll just display the very first group. So this will only show the very first group, and then it'll raise an error. Okay. So, and this is just allowing me to tag what's going on. So here's where the sorting happens. So as you can see, I've been given this population series. All right. So this is all the schools. It's been sorted. Here are the top 5. All right. So. Then here's the top 5 total. That's the next step. I just summed up these. And then here's the total, the state total. And then here's the answer, 96%. So we just divide those two numbers. So that's how you can inspect what's going on at each line of code inside your group by custom function. Because these are difficult to debug, and this is one way to kind of see what's happening line by line in the notebook. So if you don't have a fancy IDE, you can just use this. All right, so one quirk about pandas, it actually runs the first group twice, which is why you see it repeated over here. And then finally, the error is actually raised. Okay. All right, so let's time this thing. This is just saying run it, do 5 loops here. And since I called it something different, I need to use that name. So find top 5, that's what it was. Okay, so it's just this. All right. So it's just running this 5 loops of like 7 or something. All right, so it took 118 milliseconds for this. So that's sort of my baseline performance. So I have to see if I can beat this with other solutions. So that was a naive custom group by. Now, you can use the apply group by method it works very similarly as AG, but it's much more flexible. So apply doesn't enforce that you return just a single number. You can return a series or a data frame or whatever, but here it's still going to use the same exact function that I defined above. And we'll time this one. So it's a little bit faster, so not sure what the difference in the underlying code is, but it's basically doing the exact same thing. So there's not a large amount of difference here. All right, solution 1.5, use n largest. So just like we did on the whole group, we used n largest. So let's go ahead and copy this, and instead of doing sort values in dot head, we can just use n largest like this. So we'll take the top 5, and then we'll sum that, and then the total is just that right there. So let's make sure, and I overwrote that unfortunately, so I should say like n largest or something. Okay. And we should verify that this works. So find top 5 and largest, and it looks like it's showing the same numbers as at least as I recall. So let's go ahead and just put head here, and let's time this thing. All right, and see if n largest gives us any sort of speed up. So again, we're just doing 5 loops. You can change this number. It actually slowed us down a little bit. It looks like it went from 118 milliseconds to 200. So unfortunately, that doesn't give us any sort of speed up. But I like n largest. It's very clear what's happening, and there's only a small amount of code here. So sort values and then taking the head is a little bit much. A lot of typing, and this is definitely more expressive. So I like that solution actually better for readability. All right, now here's where you're going to get some speed up. So there's no point in sorting the data inside each group. So we can actually do this outside of the group first. And that's because pandas will preserve the order of the rows as it's doing the group by. So here, when we have our college data set, we can actually do this. We can sort the entire data set once and just be done with it. So for instance, when pandas is then grouping by state, and for instance goes through Arizona, the very first row will be the very largest school, and then it'll keep on going down from there. So let me call this CS for college sorted, and I'll do cs.head. So I just do sort one time. So now if I go back up and I take my top 5 again from over here. So let me just steal this function from above. All right, so we'll say top 5 sorted. So it's already pre-sorted. So I can actually wipe this out over here. It's already sorted. So all I'm going to do now, so CS, I'm going to call it on this, I'm going to use this find top 5 sorted. All right, so pop is already sorted, so I can immediately go to head, just get the top 5, and then take the sum, and then the rest will be the same. All right, so let's go ahead and do that. So again, I'm going to do, I'm using CS now and not college. So we're going to group by not pop, but state, and we're going to aggregate. We're going to map the population column to this find top 5 sorted. And looks like the results are the same. So let's just put the head right here, and then we can time this one as well. Okay, so you can see a dramatic difference. So before it was 118 or something milliseconds, and now we're down to 35 milliseconds. So that's where I did the performance. Okay, so it's dropped about a third, which is a very nice improvement. And so why is there an improvement here? So the reason there's an improvement is because we're sorting the whole data frame first. We're only doing one sort. Instead of having to do sorting every single state over and over again, we're running the same expensive sort operation. I know it's on less data, but it's still faster to just sort the entire data frame first instead of doing it within each group. And I'll talk a little bit more about that. All right, now, solution 3 is much trickier and will give you even more of a speed up. So this involves no custom function. And the end goal here is to recognize that custom functions for group bys are very expensive and they're slow. They're not optimized. Okay, so let's go ahead and pull up college again. Okay, so here it is. So we are going to pre-sort it again. So this is not. It's still going to use part of the same solution. So college.sort values, and we'll do pop again, and ascending equals false. Okay. So here's our sorted data, and we are going to group. And we're going to group by state. Now, so what I'm going to do is I'm going to assign the result of this group by to a variable called grouped, and you'll see why. Okay, so I could still call some methods from here, using method chaining, but I'm going to use the same group twice, which is why I'm going to assign it to a variable. So this still works. I could have still done ag of pop, and done sum like that, and it will sum up all the population for each state. So grouped is just that intermediate object. I'm just making an assignment statement there first. So let me not do that just yet. So now so the reason I'm doing this is that, or the method I want to show you, there is a head method on the group by object. So this is not head of just the entire data frame. This is the head of every single this is the head of every single of group. So it'll give me the top 5 rows of every single state. So if I run this, it'll just give me the top 5 rows of each state. And if you look over here, there's only 270 rows, which makes sense. So 50 times 5 is 250 plus some of the territories, and you'll get close to 270. So every state is only going to have at most, most 5 rows. We can actually double check that by getting this and doing value counts on this. So every state should have 5, except for some of the territories which have less. Okay, so that's the big trick here, is that you can call this head method and just get the first 5 rows like this. Okay, so we can just call this top 5 by state or something. And I'll just show it like this. And then we can now we actually have to perform a second group by. And I know it's kind of weird to do another group by, but now our data is shrunk from 7,500 rows to just 270 rows. So it'll actually be a pretty simple calculation, or not as computationally expensive. So that's kind of interesting. So this is sort of a trick. You do dot head, and then and let me do the aggregation like this. So now just on this top 5, so this is just the top 5, I'm going to group by again by state. So I'm guaranteed that these are only the top 5 schools by state, and now I'm going to get the sum. So top 5, I'll just call it sum. So that's by state. And then we need to get the total. So grouped is still the group of the entire data frame. So we can actually run that same thing. I'm going to do it like this. I'm going to get the pop column, and I will sum it. Okay, so we'll just say, we'll just call it total. We'll just call it state total. Okay, and then the last step is just to simply divide these two. So we have top 5 sum divided by state total. And this works because pandas automatically aligns on the index, so it can be guaranteed that they match up, and it looks like the data is the exact same that I was getting before. Okay, we'll just call this the answer. Okay, so I'm gonna I have all the steps over here in one, just so you can see it. So it's all together. So I know it's a little scattered over here, but now here it is all together. So the first step is to sort by population, descending the entire data set. Then you group by state. All right, and you assign that to a variable. Then this is the little trick. You're going to use the head method. Now this is fast. So it's able to return just the top 5 rows per state. And I'm just going to assign that to some variable. And then I'm going to take this shortened data frame and do another group by. So it sounds crazy that we're doing 2 group bys here, but I'm going to group by again by state and then aggregate the population, just those 5. So this is top 5 total. Then I go back to my grouped variable, which is for the whole data frame, and I just get the total of that, and then I divide the 2 and I get the answer. So I can just show it to you before timing this. There it is. Okay. All right, so let's go ahead and time this entire block. And you can see now I've reduced this even more. So it was like 100 milliseconds, now it's down to 10 milliseconds. When I did it, when I was not recording, I got about a 7 times difference. So here it's a little bit more than that. But you should get a substantial difference in time and performance. Okay, so here's sort of the resolution on customizing custom group by functions is to avoid them if possible. The reason you'd like to avoid them is that pandas cannot optimize your function. So for instance, pandas has some built-in methods on group bys, and those methods are written like in Python, which is very highly optimized to work for a very specific thing. So our custom function is not very specific to anything. It was like sort of like a random question, and pandas obviously does not have a solution for that. So when you write your own custom function, pandas very slowly goes through group by group and has to apply each operation independently. So it's not and it's not in Python. It's not optimized, so it can become very, very slow. And this is just a basic custom function. If you make more complex custom functions, the slowness is the performance is just going to keep on degrading. So the trick here is to try to avoid them if possible and use the built-in data frame group by methods if possible. So here our first built-in method was head. Then we used sum is built in, and then we used sum again on the total. So we used 3 separate calls to built-in group by methods here, and we did not use any custom group by function. Now so that's how we got this big speed up, and it can make a very big difference if you have a lot of data, and especially if you have a it makes a big difference if you have a lot of data, and especially if you have a lot of stuff going on in your function. So that's what I meant to say. All right, now the downside is that there's a lot of steps over here, and it's not as easy to follow, I'd say, than having a custom function, though. Maybe you could argue the other way. So that might be a little bit of a downside, but you can get a tremendous speed up of this. So another thing to notice, like if you're asking yourself, like, how can I avoid a custom function? The idea is that if you can apply a function to the whole data set, do that. You want to try to avoid applying things to groups. So, the perfect example is this sorting step. You can apply it to the entire data set, and that saves a tremendous amount of time instead of sorting it, by group. So try to do things to the entire data set and not per group, and especially not inside a custom function. All right, so that is that's a long, a very long and deep explanation on this Pandas challenge number 1. We touched on several topics, but hopefully you got a lot out of it, and there'll be a lot more of Pandas challenges to come. All right, hope you enjoyed it, and I'll see you guys in the next one.